Engine. The top visual shows the right side of new C27 engine used in the 773F-775F trucks. The bottom visual shows the left side of the new C27 engine. The 773F-775F truck engine are. The engine performance specification for the 773F truck is serial no, prefix CHX, performance spec OK5976, gross pure 544 kW, 730 horsepower, full load RPM 1800, high idle RPM 2285, low idle RPM 650, overspeed 2800 revolutions per minute. Fuel system HEUI max torque produced 1300 revolutions per minute. The engine performance specification for the 775F truck is serial no, prefix NIX, performance spec OK5979, gross pure 579 kW, 777 horsepower, full load RPM 2000, high idle RPM 2285, low idle RPM 650, overspeed 2800 revolutions per minute. Fuel system HEUI max torque produced 1300 revolutions per minute. Shown is the electronic control system component diagram for the 3412E used on the E-Series. Off-highway truck. Fuel injection is controlled by the Engine Electronic Control Module, ECM. Other system controlled by the engine include ether injection, engine start function, engine oil prelubrication. The engine ECM located on top of the engine has two 40-pin style connection. The engine ECM is cooled by fuel. Fuel flows from the fuel transfer pump through the ECM to the secondary fuel filters. Shown is the electronic control system component diagram for the C27 ACERT engine used in the 773F-775F off-highway truck. Fuel injection is controlled by the Engine Electronic Control Module, ECM. Many electronic signals are sent to the engine ECM by sensor switches and senders. The engine ECM analyzes these signals and sends signals to various output components. Output components can be relays, lamps, other controls, or solenoids. For example, based on the various input signals, the engine ECM determines when and for how long to energize the injector solenoid. When the injector solenoid are energized determines the timing of the engine. How long the solenoid are energized determines the engine speed. The engine ECM 1 is located on the right side of the engine. The engine ECM controls several systems. Those systems include either starting aid, engine start function, engine oil prelubrication, variable speed Rockford fan, engine retarding, engine derate. The engine ECM has a 120-pin connection and a 70-pin connection. The connectors are identified as J1 and J2. Be sure to identify which connector is the J1 and J2 connector before performing diagnostic tests. Occasionally, Caterpillar will make changes to the internal software that control the performance of the engine. These changes can be performed by using the WinFlash program that is part of the laptop software. Program Electronic Technician, ET. ET is used to diagnose and program the electronic control used in off-highway truck. If using the WinFlash program, a flash file must be obtained from Caterpillar and uploaded to the ECM. A 2-pin timing calibration connector is located next to the engine ECM. If the NA requires timing calibration timing sensor, Magnetic pickup is installed in the flywheel housing and connected to the timing calibration connector. Using the Caterpillar ET service tool, the timing calibration is performed automatically. This step is performed to avoid instability and ensures that no backlash is present in the timing gears during the calibration process. Timing calibration improves fuel injection accuracy by correcting for any slight tolerances that be. The crankshaft, timing gears, and timing wheel timing calibration are normally performed after the following procedures: ECM replacement, cam or crank sensor replacement, timing wheel replacement. The coolant temperature sensor 1 is located on top of the engine toward the front left side. The coolant temperature sensor is an analog sensor that is monitored by engine ECM. When the coolant temperature gets too high, the engine ECM will signal the monitoring system to display a warning. The intake air temperature sensor 2 is located on top of the engine. The sensor 2 is located toward the front right side. This intake temperature sensor is an analog sensor that is monitored by the engine ECM. The ECM monitors intake air temperature for derating the engine at high temperature, for engine shutdown at HEUI temperature, and for signaling the monitoring system in the event of a problem. The turbo outlet pressure sensor 3 are used for calculating boost. The atmospheric sensor 4 is located on top of the end time toward the front right side. The atmospheric pressure sensor is a digital sensor that is monitored by the engine ECM. The ECM monitors atmospheric for the following: altitude, the rate of air inlet, restriction, D rate, and calibration reference for other senses. The cam speed timing sensor 1 is located on the right side of the engine in the back side of the timing gear housing behind the primary fuel filter. This sensor is used as a backup for the crank speed timing sensor. If the crank speed timing sensor fails, the cam speed timing sensor allows for continuous operation. The crankshaft speed timing sensor 1 is located on the lower left of the engine toward the front side. This sensor measures engine speed and timing for control of the timing and delivery of fuel to EH of the engine cylinder. Sensing engine speed allows engine speed governing fuel, limiting down fuel injection timing. If the crank speed timing sensor fails, the cam speed timing sensor allows for continuous operation. The oil pressure sensor 2 is located on the left side of the engine. The oil pressure sensor is an analog sensor that is monitored by the engine ECM. When the oil pressure drops to low, the engine ECM will signal the monitoring system to display a warning. The ECM will also log an event that requires a factory password to clear. Shown in the top visual is the secondary fuel filter 1 and the primary fuel filter 2. These filters are located on the front right side of the engine. Shown in the lower visual is the differential fuel pressure switch 3, which is located in the top of the secondary fuel filter housing on the right side of the engine. This switch will indicate restriction on the fuel filter. A warning will be sent by the engine ECM to the machine monitor system. Fuel pressure sensor 4 is located in the top of the secondary fuel filter housing on the right side of the engine. This sensor is used to monitor fuel pressure. The engine fuel temperature sensor 5 is located in the top of the secondary fuel filter housing on the left side of the engine. The engine ECM used the fuel temperature measurement to make corrections to the fuel rate and maintain power regardless of fuel temperature within certain parameters. This feature is called fuel temperature compensation. The throttle position sensor 1 provides the desired throttle position to the engine ECM. The throttle position sensor is located behind the throttle pedal in the cap. Shown is the pre-loop pump 1 for the 773F775F truck. The pre-loop pump is located on the front of the crossmember that supports the front struts. The pump is used for both engine pre-lube and quick evac. If the truck is equipped with an ether start system, arrow, the engine ECM will automatically inject ether from the ether cylinder during cranking. The amount of automatic ether injection depends on the engine oil or jacket water coolant. Temperature. The engine ECM sends a duty cycle signal to the ether injection relay. The maximum duty cycle is 50%. A 50% duty cycle will pass the ether relay on 3 seconds and off 3 seconds. The maximum ether delivery is 10 3-second shots per minute. Each shot delivers 6 milliliters of ether. The engine ECM will energize the ether injection relay only if engine oil temperature is below 320 F. Engine coolant temperature is below 320 F. Backup for oil temperature. Engine speed is below 500 revolutions per minute. A laptop computer with the electronic technician (ET) software installed can be connected to the machine to turn the ether injection system on or off. The apparatus can also inject ether manual with the ether switch in the cab on the center console. The manual ether injection duration is 3 seconds and delivers 6 milliliters of ether each time the switch is depressed. The manual mode is disabled when engine speed is above 1,200 revolutions per minute or engine oil temperature is above 500 F. Note, the manual Start 8 ether switch is a dealer-installed option. The exhaust system 1 has been redesigned. The exhaust system no longer runs through the cooling system. Shown in the top visual is the cooling system for the 773F, 775F. The cooling system flow from the 773F remains the same as the previous 773F series truck. The cooling system flow from the 775F has changed from the previous 775E series truck. The 775F no longer has a liquid-cooled afterglow. The 775F now has an air-to-afterglow HEUI aftercooling system. Shown in the above visual is the cooling system, in color, for the 773F, 775F trucks. Coolant flows from the pump through the coolers and into the engine block. Coolant flows through the engine block and the cylinder heads. From the cylinder heads, the coolant returns to the temperature regulators and either goes directly to the water pumper, through the bypass tubes, or to the radiator. The radiator has been redesigned on the 773F, 775F. A NECT generation modular radiator, NGMR, is now used for better cooling capabilities. The NGMR has a tank mounted on the top bottom of removable cores. Shown in the above visual is the HEUI 2 system on the 773F, 775F trucks. Intake air is cooled after being compressed by the turbocharge before being routed to the engine. Combustion chamber. The 773F, 775F now has a fuel cooler 1. The fuel cooler 1 is located in front of the radiator.